Hi, good afternoon, everyone. Thank you for logging in today for our live event. My name's Eric, and we'll be getting started here in just a few minutes. You should be seeing the loading screen right now, or the please wait screen, loading screen, preview screen. Just want to make sure you guys can hear me through the audio here and see my preview screen. And we'll be getting started in just about 2 minutes here. Please let me know in the comments section you guys can hear me and can see my screen. And if you have any questions, comments, or concerns, please let me know in the comments section while we're going through the webinar today. We'll be going through some complex parts, going to be going through some 3-axis and even 4-axis milling operations on a few different parts here to sort of showcase what we have to offer in the different milling packages in BobCAD-CAM. Oops. In the meantime, I have put our phone number for technical support and also our email address. So if you have any questions after the webinar, get stuck anywhere in the software program, you can contact us at that phone number or at that email address. Let us know any questions you have, and we're more than happy to help you guys out there. We'll be getting started in just about 1 minute here. Should be able to see my preview screen, and you should be able to hear me through the audio. Just double checking here on my side that you're able to hear me. If you could let me know in the comments section there under the tech support information I provided, you could let me know you guys can hear me through the audio and we can get started here. Awesome. Thank you, Patrick. Let me know we are good to go. We'll be getting started here in just maybe 60 seconds here. Want to see if any stragglers want to join us today in our live event. We're going through programming some complex parts here in 3-axis on a couple of parts, and then one in 4-axis. Going to be looking at 3-axis Pro, 3-axis Premium, as well as the 4-axis milling package with our 4-axis Standard and 4-axis Pro. Show you guys the differences between the different milling packages there in our licensing. All right, it's 1:03. Should be getting started here now. All right, so let's get started. Hi, my name's Eric. I am the demo technician with BobCAD-CAM, and I normally do the demonstrations of the software program for potential customers. I also do the webinars here, the live events, every other Wednesday. And this one will be going through live programming of some complex parts here. Going to be going through 3-axis milling on this part file. Most of the pocketing and surfacing here of these tapered walls. Going to be going through this part file of different sides here, and then 4-axis machining to do some profiling, pocketing, things like that in here. So we'll start with the first part file here. And again, if you guys have any questions while we're running through the while we're running through the webinar today, please let me know in the comment section, and I'll be more than happy to answer any questions you guys have here. So these are part files that we've gotten from customers of ours that have had questions on if there's any better or more efficient milling operations than they are currently using. So we'll go through some of the features that we sort of started with and what we could do to optimize the milling operations here. And we'll begin by going to starting from scratch with this part file. If we wanted to start a new milling job, we go to the very top and we have this CAM tab, and we can click on New Job here. And we'll be selecting the milling job type here. We have some other machining operations or machining job types. We have turning for lathes, mill turn for a lathe with live tooling, and we also offer wire EDM machining. Under milling, we also offer laser, plasma, and water jet machining here. We can select one of our milling machines. We offer 4- and 5-axis milling, but we'll be going through the 3-axis milling for this part file specifically. So we go here to BC3X mill. This is our BobCAD 3-axis milling machine. And in the G-code formatting for this machine, it will process a G-code of a FNUC-based format of G-code. So from this machine, I go to the stock wizard. We can define our workpiece. So I'm going to select my finished 3D model here to let the software know our workpiece so that we can see that in our simulation. We can define our stock next, and in the rectangular stock type up at the top here, it will create a bounding box around our part file or around a drawing or anything, maybe an assembly if we want to create a stock around that. We can also define it from a cylinder, and we can also extrude it out from wireframe or select an existing solid model or STL model. So if we had a 3D model of what we're starting with, for example, if we're starting from a casting, we can let the software know exactly how much material is remaining so that we can avoid any air cutting. So I'm going to go to rectangle and I'm going to click calculate stock again. If I wanted to add more to the stock, you can see our X, Y, and Z dimensions here for the stock. And then we can go to our next page. And this is where we can define our machine setup. This is where we are defining our G54 work offset location. So currently, you can see it's sitting here inside of the stock, or inside of the stock and in the middle of the part file here, because it's always starting at the CAD origin location. So if I want to change it to any location here, I can highlight this origin box, and I can click on any of these points that show up, or any geometry I can create in the part file here, and that'll be my new G54 work offset location. Then from there I scroll down and click OK. And then after that process, we go through the milling operations. And under this milling job that I have just created, I can right-click on Machine Setup 1 and go to our different milling operations where we have drilling and tapping, counterbore operations, and then Mill 2 axis. We'll just take a look at those milling operations to start with, and then we'll get into the 3-axis milling. So in Mill 2 axis, this is considered 2.5-axis machining. With our available operations here on the right, we have our profile roughing and our profile finish operation, pocketing, facing, engraving, chamfer mill, corner rounding, all of the basic milling operations here. It's considered 2.5-axis machining because this is where the tool will come down in Z, it'll move around in X and Y, and then it will go back up in Z. So it's not going to be moving all 3 axes simultaneously. It'll be moving down in Z first, then move in X and Y. If it needs to do another depth, it'll go down in Z again, and then move in X and Y. So if you look at the pocketing operation, it's going to go down in X, it's going to pocket that level. Then if it needs to go down to the next depth of cut, it'll go down to in Z, and then it'll move in X and Y. A little different than the 3 axis where it can move X, Y, and Z simultaneously. So that's sort of our first milling package here. All of this mill 2 axis, that first milling package is considered Mill Express in BobCAD-CAM. If I cancel out of this feature here, I can right click on Machine Setup 1 again and go to Mill 3 axis. And here under the machining strategy operations, we have our 3-axis standard and our 3-axis pro. I'll get into the pro machining that we're going into today, take a look at a couple of the premium milling operations, and then look at the 4-axis milling operations after these couple part files first. So we'll get into mill 3-axis standard first. We have Z-level rough, Z-level finish, planar toolpath, just going back and forth across the surfaces here, spiral toolpath, radial, and plunge rough. And then we have our 3-axis pro milling operations where we have advanced rough, advanced finish, advanced planar. You can see we have the standard planar, advanced planar, standard rough, advanced rough. So basically the same kind of milling operations, but a lot more optimization options that I can show you in the 3-axis pro here. Some other 3-axis pro milling operations, some finish operations where we have flatlands, which will detect all the flat areas and mill those out with a flat end mill. Equidistant, sort of a spiral toolpath. It'll start around a boundary I select and then spiral around, giving us a better surface finish. Pencil mill to mill any fillets, and project curves where we can project a 2D shape onto a 3D surface to do a 3D engraving operation. And so I'll cancel out of the 3-axis milling features, and I'll delete the milling job that I had just created because I've got one set up already. So these icons here to the left of these features you can see in the CAM tree, these are all blanked out with the icon of an eyeball with the black cross through it so that it's blanked out. All of them are blanked out at the moment, and some of them have this icon to the right of them also with a controller icon with a red X, and that's our post yes no option. So when you see the icon with a red X, it is not going to post the G-code for this feature. It's also not going to simulate the operations here, because these are the operations we started with, and then we'll look at some of the operations that are a little more optimized, we can say. So a couple 2-axis features here. I'll show these where we started with a pocket operation at one level and then another pocket operation at this level. So this will sort of showcase where the 2-axis milling operations, it'll only be able to do, how do I describe this? It'll only be able to do certain geometry at a certain level, if that makes sense. This geometry here for this one of the main pocket will get down to this level, but if there are additional pockets that are going deeper, we could do it in a separate 2-axis milling feature like this and do a pocket and profile milling operation to finish that up. Or we could go into the 3-axis milling feature of an advanced rough, and what I did was I selected the pocket, the main pocket, the inner pockets here, the 2 holes and the slot here, and also the tapered walls. I'm doing it in all one operation here to rough it out. And to start with, it's a little different than the 2-axis features. So the 2-axis features, the geometry selection, are going to be either surface edges or wireframe, and it's all going to be in a 2D sense as if we were looking at it from a top view here. So you can see the geometry selected. Oops. Well, you can see the geometry selection here, a preview of it, are all just the surface edges around the pocket here. And so that's the way we select our geometry for the 2-axis features. And for the 3-axis features, we select first. If we go right into mill 3-axis, we first select our geometry, and then we select our boundary. And the geometry selection, good rule of thumb here, is just selecting the solid model. And the reason for that, so I checked this box over at the top left, you can see select solid body. I can select the solid model. And that's a good rule of thumb for us, because if there was any obstruction, say if there was a boss on top here that was protruding out, we would want to select that geometry so that BobCAD understands, recognizes that geometry, and will avoid any collisions with any of the toolpath for that. So that's part of it. Also part of it, not to criticize the other operations that we are looking at, the less optimized milling operations, you could say. But we're looking at the planar toolpath, and if we backplot it by expanding the feature, right-clicking on an operation and going to backplot, we can sort of simulate the toolpath here in the CAD geometry. And we can see that there's going to be a collision here, because with this planar toolpath we started with, how they selected it was the geometry of only the surface here. Now in 3-axis features, it BobCAD, if you don't select the geometry, BobCAD doesn't recognize that geometry to avoid. So with only selecting the surface, it doesn't understand, hey, there's a sidewall here we need to ignore, and without selecting it as geometry, it will gouge into that corner there. So just a good rule of thumb there to select our geometry as the 3D model entirely, and then the boundary that I selected. Now I started with a boundary of, I extracted the edges of these surfaces here, and then I extended them out a little bit further as well. I can explain that a little bit more here. But with the wireframe, how I created that was in BobCAD. We've got a great CAD feature for that, going into Create 2D, going into Extract Edges. And I can either select surface edges, or I can just select some of the surfaces here and trim away what I don't need or extend out what I want there. And then I can project it to a Z plane. And I projected it to Z0 here so that everything's flat at Z0. And again, I extended out the lines a little bit. And yeah, so from there, I'll show the solid again, go to the CAM tree, we'll go through the advanced rough here of the geometry as the 3D model, the boundary of the wireframe here. Now, we did an advanced rough operation. Set our work offset number on the next page. So number 1 is G54, 2 is G55, 56, and so on if we're setting multiple work offsets at the table. We have a standard UI and an advanced UI. We'll get into that a little bit later with our next part file that we're going to be looking at. Next, we're setting up the tool. This customer had a 5mm flat end mill. And then we have our different cut patterns. So we start with parallel, that I'll show you. We can zig or zigzag back and forth inside of the pocket, going from one side to the next. Then we have our offset options. Offset is where it will start at the center of the pocket and step over, working its way out to the outside of the pocket. Offset in is the opposite, where it'll start from the outside, from the walls there, and work its way in, stepping over each time. Then we have a couple of high-speed machining options with, instead of stepping over, morph spiral will start at the center, continually spiral its way out until it gets to the outside walls, instead of stepping over and wasting time that way. And we also have adaptive roughing, which is sort of the same thing, starting towards the center and spiraling its way out. But if we do a one-directional cut, you can see once it gets to one edge, the tool can retract just a fraction of an amount and rapid across to the next location, giving us our trichoidal milling. So if you're familiar with other CAM software programs, some programs call this dynamic roughing or dynamic machining. This is essentially the same thing. It's called adaptive roughing, just a different term, but the same exact toolpath with tricoidal milling. Our next page, we have a depth of cut amount, a step over amount. We can set an allowance for a certain amount for the finish pass to clean up. On the next page, here's where we have our entry options. So if we want to plunge down into the stock, ramp in, linear move entering in, or spiral, a helical interpolation down into the material. We also have, since I've set the boundary a little bit further past, I haven't closed off the tool path from starting from the outside now and working its way in. And to set that up, all I have to do on this leads page is I uncheck this box center cutting tool, where it will, BobCAD could understand where the side of the stock starts there and work its way in that way. You can see that tool path now. And if I backplot, you can see it starts from the outside of the stock and works its way in. The only thing at the moment with this toolpath, however, is with the different depths here with the holes and the slot, it doesn't give us any toolpath down in those depths, only because BobCAD understands there's no opening to the sides of them. So that's why I started with just a plunge operation with this. Next, we'll get into the options page. We'll take a look at some of the pro functionality here, where we offer rest roughing, where the tool, I can set the previous tool. Sorry, let me start from the beginning. With rest roughing, if we had a previous roughing operation before this, we can set a previous tool diameter and corner radius of that tool. The software will calculate any areas the previous tool couldn't enter and create that tool path for us. So essentially it's going to start right where we left off from the previous operation and avoid any air cutting this way. I'll uncheck that box for now, and we'll go down here. I turned on this machine flatlands option, also in the pro functionality, where it will detect all the flat areas and come back and mill those out with a flat end mill. So for example, if I have my depth of cut here set to a 1/2 inch, and if this level down here is down 600 thou, for example, we would only be doing one depth of cut if we didn't have that flatlands option turned on. It would just go down that depth of cut of a 1/2 inch, and it would leave that extra 100 thou material down at the bottom. With the flatlands option, it will come back, recognize that extra material, and do that extra pass for us automatically. So it's a great option to have there. Then our next page, linking for each step over, our gouge check page. So if there was any gouging with any of these milling operations, we can make sure the tool avoids those areas. And an advanced feed rate page. So if I'm not able to set a rapid rate at the controller, I can convert rapid moves to feed moves here, and I can set that rate. I can set my feed rate for linking between groups of geometry to speed up that process. And we also have an adaptive feed rate option, where I can set a minimum and a maximum feed rate. And for example, when the tool is getting into larger material, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. So a lot of those options there in the 3-axis Pro toolpaths that aren't offered in the 3-axis standard that can be really beneficial. So we'll get back to the advanced rough here. So that's the toolpath. Thought I turned it off. There we go. And make sure it's going, yep, so it's going down into the slots. Okay, cool. So we have the advanced rough to start with. And if we'd like, we can just start our simulation with just roughing here. I'll turn off all of the other milling operations, and I'll hit start simulation up at the top. So this is just the flat end mill, and then we'll be using a ball end mill for the finish operations here. Don saying, any reason why you used a chamfer in the corners rather than the radius? I've only used this flat end mill for the roughing so far, and we'll be using a ball end mill for the other milling operations. So I'm not sure which chamfer tool you saw there, Don. Let me know if there was anything that you had questions on with that, because I don't think I'll be using a chamfer tool for this part file at least. But yeah, if you had something in there you had a question on, please let me know about a chamfer tool in the 2D milling section. I'll take a look at that. Before we get into that, we'll take a look at the roughing here. So you can see it's going down 100 thou every time at each depth of cut here. You can see at the very top, it gives us our estimated cycle time. So it says it will take about 12.5 minutes for this roughing operation, and that's based on the feed rate that I have set. And now on the other side here, it goes down 100 thou. And then once it goes down to the bottom here, you'll see it'll come back up doing an additional couple of passes at each depth here. So it'll remove more material in between the 100 thou depth of cut for each one there. And that option is set under the advanced rough. Under the depth of cut and the step over options here, we have number of intermediate steps. So that's what that option is for. It will do 2 additional passes in between the 100 thou to remove even more material for the finish operation to have less material to clean up there. So a lot of really useful stuff in there for the milling operations. Now this is our first 2-axis feature. This is a flat end mill, and second 2-axis feature is another flat end mill. I'm not sure which chamfer tool you're referring to. We had a planar tool path. This one has a corner radius. It may be the diagram you're looking at. I'm not sure there, Don. But yeah, I don't see a chamfer tool necessarily. Yeah, I don't think I'll be using any chamfer tools with this. Just a flat end mill. And then we'll be looking, so flat end mill for the advanced rough to mill everything out with the pockets here except for the tapered walls. And we'll be taking a look at the planar toolpath first, of how that toolpath would look, and then something in the premium toolpaths to get an even better finish operation here, better toolpath than this. But we'll take a look at the advanced planar first. It's just going back and forth across the surface here and coming back up to the top, getting as best as it can here. And again, with the geometry selection here, I selected the 3D model, selected the boundary of the 2 surfaces here that I'm containing the toolpath inside of. Other than that, I'll be doing an advanced planar toolpath, something that's more efficient in the advanced planar rather than the standard planar toolpath is right here under the parameters page. We have a standard step over option, so I can set a step over of 10 thou all the way across the surfaces, for example. I also have an adaptive step over option, so maybe I'll want it to get down to 5 thou if necessary in the corners to clean up the corners a little bit better, so that it doesn't have to do 5 thou all the way across the part, just where it needs to. So sort of like a 2-in-1 planar toolpath in here. Instead of doing 100 thou all the way, instead of doing 10 thou all the way across and then doing an additional operation 5 thou all the way across, we can let BobCAD automatically set where it needs to do 5 thou in the corners there. Then we have our entry options again, and our rest machining option here. Linking for each step over, again, our Gauss check page, advanced feed rates, MDI page for this one. We didn't go over, this one's for manual data input. So if there was if I wanted to add a spindle speed, a tool change, work offset, or if I wanted to add any raw text. If I wanted to add a comment before or after an operation, I can highlight raw text, highlight after operation, add that command in, and type in anything I want here. As raw text, it'll just type in, or it'll just add the text into the G code. If I click on comment here, it will add parentheses to the comment there, to the text. So I'll hit finish because I didn't really do anything different there. But you can see in the back plot here, on the other side, I'm stepping over. So it's really not doing anything here. It's just looking at, if I look at it from a top view and I hide the tool holder, just look at the tool there. This is not going to be, it's only creating tool path inside of the boundary I've selected and not touching anything really here yet, because we're trying to focus on the bottom here. Speed up the process here. And now it's finally touching down at the bottom of the surface here, but it's not getting anything in these corners yet. And the reason for that is because it is going up, and you can see the tool path. A planar tool path is just going to go up and down across the surfaces here. That is set under the patterns page in the planar toolpath under this lace angle option. So 90 degrees will go up and down across the y-axis for this example. If I set it to 0, it'll go back and forth horizontally along the x-axis. If I hit compute, we can see that. And I can do anything between 0 and 360. For example, if I set it to 45, it'll do sort of a 45-degree angle across. Very similar to this angle right here, but not the same as this angle here. So it's not going to create toolpath on one angle and then on the other angle meeting those sides. So that's where the premium toolpath can really be useful. So Don, with your question, in the section used to define the boundary. Yeah, so the boundaries here is basically like this, where I've selected my surface edges for this planar toolpath. In the roughing, my boundary, we'll see it a little bit better in the wireframe selection. If I hide the solid, this is how I selected the boundary. It's contained, yeah, it might be sort of a visual thing where it's flattened, but it sort of looks like it's on a chamfer. The only reason why it looks like that is because it was flattened down to a z-plane, and it's just in a two-dimensional shape following along the surface edges of that main pocket there, that main cutout we're going for. So I didn't add anything necessarily other than the outside areas here so that the tool can come out here and work its way into the side of the tool. If I don't extend out the boundary a little bit further at the top and bottom here, then BobCAD would think, oh, there's no area here to start from. So that's why I extended these out, and I just flattened the geometry. So that's where you kind of see a chamfer there, I think. But yeah, good question. Let me know if you guys have any other questions moving forward here. We went through the roughing with this part file. We went through the planar toolpath for top and bottom. Now the planar toolpath, again, isn't very efficient. We'll even take a look at the simulation first. Once I set this to 0 again, or 90 again. For the angle direction, just going up and down here. And then we'll get into, so we have gone through the Mill 3-Axis Pro with our advanced rough here, and a 3-Axis Pro toolpath for a finish with our advanced planar. Now the advanced planar in 3-Axis Pro isn't going to be the most efficient here, for those tapered walls, we'll get into the 3-axis premium to see how to clean up these tapered walls a little bit better here. Yeah, Patrick, good question. How are you going to mill the sharp corner on the tapered surface? Not really able to if we're just going to be keeping it flat like this. You can see it's gonna, since the tool shape is a ball end mill, it's not going to be able to get into the corners perfectly here. If we wanted to, we could maybe tilt it if we were able to fixture it a different way and use a flat end mill to go across in this manner. We'll be looking at something similar to that in the next part file. But yeah, we're just going to get the best that we can with this one with a ball end mill in our 3-axis premium toolpath. It's going to look a lot better than what we have so far. To see what we have so far with the remaining stock, we can view that in our simulation by going to this analysis tab down at the bottom of our simulation. And you can't see that because my head's in the way, so I'll move myself out of the way here. So down at the bottom right corner here of our simulation, you can see this yellow tab called Analysis. And under this drop-down of the Analysis tab, we have the fourth one down is called Deviation. If I hit refresh, this refresh button next to deviation, it will load different colors on the stock depending on how much material is remaining getting to the finished area. So you can see like the pocket, the slot here in green is cut to size with a cut tolerance of plus or minus 8 thousandths of an inch. If we look at, in between this boss here and over here, we're looking at a dark blue color right here of more than 64 thou remaining in these areas here. We should be able to get a little bit better into these corners than the extra 10 thou, 20 thou remaining there. And we didn't even touch this area, so we can take a look at that as well. Also taking a look at the tapered walls, the tapered, this chamfer around the pocket as well. So I'll close out a simulation. I'll turn off the planar toolpath. I'll click Post No here. And then under the next one is this premium, these two premium operations with these two features. To find those, you first have to have 3-axis premium unlocked on your license. And if you don't have it on your license, you can always contact your account manager and ask how much it is to pay the difference for the 3-axis premium. But to see if you have it, you can go to File, go to Help, and then go to Show License Status in BobCAD down at the bottom here to see if that 3-axis premium is checked off on your license here. I've got the latest and greatest with an in-house license. I've got the 3-axis Pro, 3-axis Premium, and then we'll be taking a look at 4-axis Standard and Pro as well in the next couple part files. So 3-axis Premium, that's unlocked in here, and that is found in the CAM tree. If we right-click on Machine Setup 1, that is found under Mill Multi-Axis. Now there's sort of a history behind that, in the older versions, it was only unlocked in the multi-axis package, but now we offer 3-axis premium. So if we go to Mill Multi-Axis, we click on that, and that's all of our surface-based toolpaths here, and also the deburring is unlocked in 3-axis premium. These other ones up towards the top are in 4 and 5-axis. Turn milling is for 4-axis for a rotary table. Port machining is 5-axis for porting. Multi-blade is 5-axis for impellers. We offer swarf machining in 5-axis, multi-axis machining for roughing, and wireframe to follow along wireframe at a certain rotary angle. So we've got a lot of stuff there in 4 and 5-axis we can go through in another webinar. Today we're going to be looking at the 3-axis premium. Again, that offers deburring So you could use a ball end mill or a chamfer tool to follow along any edges. And you also have the surface-based toolpaths. The two that we're going to be looking at today would be the morph between two curves first. And you can see an example of this where the tool will start at a certain edge and morph the tool path from one edge to the next one selected, going across all the surfaces in between. So you can see like this hourglass shape is starting at the top and working its way down. It starts on that edge and creates toolpath until it gets to the last edge and follows along that edge as well. So really helpful for this trapezoid shape here, or both of the trapezoid shapes on either side of this part, where it's going to start along here, it's going to morph the toolpath all the way across and end on this edge here as well. Again, as you guys noted, it's not going to get into the corners perfectly just because it's a ball end mill. It'll be left with that extra material there. But we'll be looking at our next part file to see how to change the machine setup, change the work offset to use a flat end mill to get into those corners. But best we can with this one machine setup, we can start by going to the morph between two curves. We go to the next page where we can set our work offset number. Our next page is where we can set up the tool. We're using a 6mm ball end mill. We can set our cutting feed rate. I'll talk about the feed rate for a second here as well. We can set up our spindle RPM and cutting feed rate manually here, or we can use system feeds and speeds, and that will calculate these feed rates based on the material type selected. And that is found if you go to the CAM tree under stock, you can expand that option here. So if you click on that drop down, you can see the material library here. And I can double click on it based on if I'm machining from steel, aluminum, different types of plastic. We have feeds and speeds built into the software program. And you can see that the cutting feed rate changes based on if I'm cutting from aluminum now. So speed up that process and it'll cut down on our cycle times in the simulation as well. Then we go to our parameters page. And this is the same format as if we were looking at it in the premium UI. Standard, if we go to 3-axis Pro for just a second, standard UI and advanced UI. So the advanced UI is the same sort of layout as we're looking at in the 3-axis premium with these tabs to select our geometry, select a step over, gouge check, linking for each step over. So a few additional options in the advanced UI that we'll be looking at now as well. Timothy, how do you get the MDI tab? Now, MDI is a newer option in V35 and V36. So if you're on an older version, you might not have that MDI tab. But yeah, that should be automatic on all of the milling operations in the newer versions. So if we go back to the parameters tab under 3-axis premium, we first select, what I normally do is I first select the drive surfaces. So I click drive surface here and then click, am I clicking both of them? No, I'm just focusing on this one. So I just clicked on this surface. Then I clicked first curve, which would be this one here. I just select that surface edge. And then our second edge would be this one here. Then we have our offset option. So it's like leaving an allowance. We can leave a certain amount of material for a finish pass to clean up. I'm setting it to 0 because this is a finish operation. Down here at the bottom, what I really like in the premium toolpaths is we can set up a maximum step over, or based on the tool that we have selected, we can define the step over based on our desired cusp height or scallop height. Or if there's a specific deviation we need from the stock down to the workpiece, we can select that here. Say, for example, if I wanted a cusp height of no more than plus or minus half a thou, I can type that in here. And you can see that the step over automatically updates to the specific cusp height that I want there. So there's no guesswork in going into simulation, looking at the deviation report and seeing if there's too much material remaining. We can make sure that we want to get down to the specific tolerance levels here, specific deviation. Our next tab over here at the top is tool axis control. It's going to be 3 axis. We could also select 4 or 5 axis machining here if we have that unlocked on our license. Next tab over, we have gouge check. So I selected, which surfaces did I select? I selected these surfaces so that the tool doesn't gouge into these walls here. Then, other than that, we have linking for each step over. We have a lead in and lead out option here. Roughing. So if I wanted to do multiple passes, I can set the number of roughing passes and how far they're going to be spaced out, number of finish passes and how far they're going to be spaced out. So a lot of good stuff here in the 3-axis premium. One other that I like here is if we compute the toolpath, you can see that it's not getting, if we backplot this here and we go across, I'm going to move the progress over here. You can see that there would be additional material remaining in this area from the ball end mill. Hard to see, but especially right here at this location, the top of the surface right here, it's not getting out to it. So if I wanted to make sure that it's getting out to there and that it's going past the surface here, in the 3-axis premium features under parameters, there is this checkbox for extend/trim. And this button, this one's really useful here. Under this page, you can set how far you want to extend past the surface, past the tool path in a linear direction, and then also side extensions. So if we wanted to start a couple passes beforehand and work our way in, we can do that with the side extensions, and then we can also extend the toolpath outward. And I'm going 1/4 of an inch past the surfaces to make sure the toolpath goes past the surfaces there. So I'll turn that one on here as well. And then the next one we're looking at, we went through morph between 2 curves. The next one we're looking at is parallel to multiple curves. So you can see the geometry selection for this one. It's a little different. You have your drive surfaces, where we're focusing on this chamfer right here. All of those surfaces selected. And then the parallel to multiple curves, all we do is select one first curve here, which would be the top, or it could be the bottom if we wanted to start from the bottom, work our way up, and it will create an array of the toolpath down the surfaces selected there. I'm going to go to extend and trim on this one, and we'll look at how it looks originally. Would be like this. So you can see maybe I want to extend it out first and last, and then add a couple passes before it and a couple passes after. So I'm going to do that here under extend trim. I like typing in the value. I don't care for the percentage of the tool diameter. I know that I just want to go 1/2 inch for each one of them here, because I'm in millimeter. I don't know what the size of the tool is, so I just type in the actual amount rather than the percentage of the tool diameter. So I click compute, and then I can see the tool path here. That is crazy far. So let's change that extension, especially this one. I'm just going to do 100 thou, starting and ending, and let's do 1/4 inch for the tangential extensions. So it's going to start up top here, 100 thousandths above, work its way across, and it's going to extend out 1/4 of an inch. Still doesn't like some of this stuff here. That's really far out. I'm just gonna do like an extra 5 thou or something. Let's do 10 for each one of these. But this is our last operation here. I'll just recompute this. We'll take a look at the simulation of what we've worked on with these operations here. Go to Start Simulation. And yes, to answer your question, Timothy, it should be in V12. I think V11 and V12 should have the MDI page. Everything should be up to par in all of our plugins as well there. Every update in one software program, it'll be updated in all of them for BobCAD and BobCAM. So we start with the roughing operation, and based on machining from aluminum, we can see that it is about 14 minutes and 10 seconds. And normally it has different colors based on the analysis tab here. If I just set it to none, it leaves it at the original color until I want to look at that deviation report. So here's the roughing operation. And then we'll look at the, after that, it'll be the morph between two curves here. So you can see it started from that edge over here, works its way across. So pretty good all the way across these surfaces. This one it didn't get across just because that's not part of the geometry selected. So what I may want to do is add this to my geometry, maybe cut this surface right here and then add it to the geometry selection. But we'll go to the deviation report. So yeah, as someone was mentioning earlier, the ball end mill isn't able to get into this corner. So, I mean, really the only way I could see this being machined on that corner there would be if we changed the machine setup to have it tilted along that angle to be able to use a flat end mill in the corners there. That'd be the only way I could see doing that. And we'll take a look at an option for that in our next part file that we're going over. I didn't see this one here. Let me turn that parallel to multiple curves on as well. Yeah. So I'll skip the next operation for roughing, skip the morph between two curves, and we'll look at this one here, where again it just starts from the edge that I selected there and works its way down to do that chamfer there. So a couple of great features to be able to finish up surfaces rather than the planar just going back and forth. It actually follows along geometry here with the premium surface-based toolpaths here to give you a better surface finish and actually follow along the surfaces there. If you guys have any questions with this part file, please let me know. If not, we'll get into the next part file where we'll be looking at setting multiple machine setups so that we could follow along a corner like this with a flat end mill and mill that to size. It's going to be in this next part file here. So we have a 3D model, and we're starting, with this example here, we're starting with a 3-axis toolpath here. Then we're changing the machine setup. This is pretty nice where we're just going 90 degrees for each one until we get to this one. We have to find a way to be able to set it up for this work offset parallel to that one, so we get right down to that flat there. Now that'll probably be set up a little bit sooner in the milling job than I have it at the moment. All right. Yeah, so let's look at some of these. So the customer had a milling job and he separated these machine setups in different milling jobs, which is definitely, uh, it's doable. And I think they were doing it because they want to be able to run the one milling job and then enter the next G code program. Um, this one here, it will give you an optional stop in between the machine setups so that it will turn off and then you'll be able to refixture it. Let me see how this works out. So if I had that one, that should be good. Yeah. So we'll do this first and then we'll do this one next. Okay. Yeah. Cool. So it's a little out of order, but we can always change the order of operations. We'll take a look at that. Yep. Yeah. So yeah, good point, Patrick. I normally turn off the stock so that it's easier to see the part file here and seeing the different bosses we're trying to go around and mill out these pockets here. It's actually pretty cool. So we start with the milling job. Again, define our stock, define the machine setup that's set up here on the corner of the stock there. And from there, I right click on machine setup 1 and I went to mill 3 axis, selected our geometry. And for this one, I have no boundary because there's no areas I want to separate out, if that makes sense. Like in our first part file, I didn't want the uh, roughing operation to get into these holes here, into these pockets or anywhere else. I didn't want to do the chamfer either necessarily. So to avoid those areas, I just created a boundary inside of the main pocket there. For this one, there's no areas I need to avoid, so I don't have a boundary. And you can see there's nothing selected for the boundary because there's a red plus next to it. If there's that icon to the left of anything, that means it's not selected. So if I go into the feature for this first machine setup, we created an advanced roughing operation and a planar toolpath. Set our work offset number. Set our tool to start with. It's a 1/2 inch flat end mill. Set the spindle RPM and cutting feed rate. Next, we have our cut pattern. I just have it at offset out. So it starts, works its way in, and just steps over until it gets to the edges of the part there. We've got a depth of cut, step over amount, the number of intermediate steps. That's really useful to clean up as much material in this roughing operation so that there's less material for the finish pass to clean up. We're leaving 10 thou for the finish pass to clean up. And then our next page, we're just doing center cutting tool. We could turn that off so that it starts from the sides of the stock, works its way in. Again, we have those options for roughing, rest roughing, flat lands option, linking for each step over, gouge check page. Now this advanced posting, that's for the specific machine we're using. A little different. Advanced feed rates, MDI page. So all the stuff we really went over earlier, and then we're using a ball end mill for a planar toolpath afterward. The lace angle of 0 degrees will be going back and forth along the x-axis there. The roughing here looks pretty good. I'll recompute it just because now we're starting. Yep, no, I didn't want that. That's probably with this here. If not, I can just click. Okay. Yep, that looks good. Yeah, I wanted to remove that area as well. That'll sort of get down to the next machine setup we want to get to once we rotate this stock around. So let's take a look at just the first roughing and planar toolpath here in simulation. So I'll turn everything off in the milling job except for the feature 3 axis, turn that one on. And then I'll hit run. So there's our roughing, and then the planar toolpath with the, oh, no, still roughing here. Roughing with the flat end mill, and then now is the planar toolpath. You can see how much the intermediate steps removes so that the planar toolpath can come back and mill that out. Basically just 10 thou, maybe 15 or 20 thou remaining, so that there's not too much for the finish pass to clean up there. But yeah, the number of intermediate steps to do a couple of additional passes after our original depth of cut can be really useful there. So this is where we're starting off. We had our original machine set up right here, and now we'll be able to rotate it around at this location and have that specific angle to work off of. So here's our first machine setup, and we're going into the next machine setup here all the way around, and we'll be doing an open pocket operation and a profile around the bosses here. Now it's a little out of order here. You know, we had our machine setup 1 here. If I rotate it correctly, hard to see without the stock at the moment. So with this one, that's how it's touched off. Next we've got, next how I set it up was pocket and profile those pockets and then facing on that side. But if we want to do this one next, what I could do is I could drag and drop this machine setup right below machine setup 1, and I could rename them. Just right click and hit rename. This is number 2, and then this one would be number 3, and then the last one would be number 4. I like doing it this way because that way in the CAM tree I can see the actual order of operations that how they're set up. But I also want to make sure that when it pertains to the simulation and the posting of the G code, it's going to be reflected on how it's set up in the CAM tree. And to verify that, we have this operations tab down at the bottom. Now, if you don't see it here next to the CAM tree, if it's over on the other side, or if you don't see it, it may be closed out. And if you, to reopen any of these pages, you can right click up at the top of your screen here, and you can select which pages you want to open. If you want to keep the CAD tree open, the CAM tree, the operations manager, the tool tree manager, you can show or hide any of these here. So under operations, we can see that it's doing the advanced rough and the advanced planar first. And then it's doing that pocket and profile next that I want. And then doing the next pocket and profile, and then that facing operation at the end there. Just sort of roughing out all of that on that side, you can see. Now, if I wanted it a different way, I can highlight, maybe if I wanted to highlight this facing operation, change that and move it up in the order of operations. I can move it up or move it down here. Or I can sort them exactly to how I want them with this optimization type here on the left side. Now this optimization type by feature is going to be all the milling operations reflected in the CAM tree here by individual feature in the CAM tree. Under the optimization type, the second option is by tool per setup or by tool. So by tool would mean it'll do all of the milling operations with the roughing tool first, and then it'll do all of the milling operations with a ball end mill, and then it'll do all of the drilling operations with a specific with a specific drill that you have set up. So that's by tool, and then by tool per setup. Now, by tool would be within the whole CAM tree. if there's all the roughing operations, it'll refixture, it'll do that in the G code and create and do the roughing operations under each setup first, and then it'll come back and do the finish operations, then do the drill operations. The next one is by tool per setup. So it'll do all the roughing operations under machine setup 1 first. Then it'll do the finish operations under machine setup 1 and the drilling operations under machine setup 1. Then move to machine setup 2 and sort all of those milling operations next. So that's what the difference is between all of these optimization types. I usually have it by feature, just so that I know everything that is sorted here that I have in the CAM tree reflects how it is in the operations tree. Makes things easier for me, at least. Now you can see down at the bottom here, we have this operation tree. If you guys are familiar with the older versions of BobCAD, you have, or you used to have, the machining order under the milling job. That's the same thing as our operations tree here, just to not to confuse you guys there. So operations tree, and then down at the bottom we have our tool tree also. This is a newer option where if we had, say, all of these features you see with the pocket, profile finish, with the 1/4" end mill. For example, if the tool broke on you and you needed to change the tool number or needed to change the tool geometry, you can just right click on the tool here under the tool tree and replace the tool. And it'll ask you, the tool is currently in use. Do you want to change the tool for all operations in that use it? Yes, and then you can change the tool here and select the tool, and then it will replace all the tools for those operations for you in the milling job. So that is it's really helpful. You don't have to go into the CAM tree and find each operation that tool is being utilized with. You can do it in that tool tree page. Other than that, that's about it with how we had this set up. We'll get into the next part file. Other than, this is how we set up new machine setups. From machine setup 1, I right click, I go to additional functions, and go to add or insert setup. From the setup that I just created, I can right click and edit. Say if I'm touching off at this corner here, I can click on origin, click on the new work offset location, change my X, Y, and Z directions accordingly. So now Z is pointed up and we can do a milling operation down from this side of the surface. If I'm able to fixture it where it's on this angle, I can highlight Y direction and highlight the surface edge that's parallel to my new Y axis like that. So that's how I'd be able to angle it to do a pocket operation and profile on that side. And now we'll take a look at that simulation with these milling operations. And then we'll get into our last part file. Let me know if you guys have any questions with this. Thank you, Leon. Glad you were able to join us today, and everybody else. And we have gone through the 3-axis milling today, and we'll be getting into the 4-axis milling next. So thanks, Leon, for the great comment there. Thank you guys for joining us and being part of, commenting in here about our live events. We do these live events every other Wednesday, and we got some part files from you guys, so we thought this live event would be great to be able to show you guys operations with your specific part files. Let us know if you have any questions on these, and also what you guys would like to see in the future too. We want to make sure that these live events are tailored specifically to what you guys are having questions on in the software program. So here's the roughing and finish first on this side. Then it would put a stop in the program for us to refixture at a different location. Again, this is 3-axis because it doesn't get all the way past, does it? But anyways, this is 3-axis where we can refixture it. We also have the 4-axis where we can change the index locations as well. Now on this side, that surface isn't far enough over. Maybe we would want to do the facing first. So I'll go back to the Operations tab, move the facing up a little bit. I think that's what I was having trouble with. So I'll move that up in the list here before the pocket. So I'll skip the roughing and finish in 3-axis. We'll get to the next one where it'll face off this area first. Remove all of that material. Doing multiple depths of cut there. The tool's not, this is pretty helpful. The tool's not long enough, so it actually ran into that area there in red. So you have a good verification to see if anything is having a collision there. So that's pretty useful. Then it will refixture to this side and do the open pockets on this side. But yeah, then once everything's cut to size, and everything, there's no collisions like this one here, we go back in the tool page and change the tool here to make it longer for that one. But then once everything is cut to size like that, we can close out of simulation. We can go to the top and go to post. It will generate the G-code here on the right-hand side, where I can right-click, save it, and save the NC file onto a flash drive to send it over to the controller from there. We also have RS-232 communication. So if you have an older machine, you can right-click on NC Editor, and we have a DNC option. So if you have a cable from your computer to the machine, you can set the port number and all of those settings to send or receive from a CNC machine. So I'm going to close out these two files. We'll get into 3-axis and 4-axis milling in this last part file. Please let me know if you guys have any questions moving forward here. And I'll blank out everything so we can see the part file we're working with here. Basically what I'm focusing on is this thread here and drilling. You might need to pocket this hole, larger hole here, and then profile cutting and pocketing here as well. So we started with our stock, which is cylindrical like this. I just did a drilling operation for this size here. It's 708 for the size of the diameter here. All I did was go to my machine setup from the center of the stock here with my BC 4-axis mill. This 4-axis mill in BobCAD has an A-axis rotation, so the rotation is around the X-axis. And I right-click, go to Mill Drill Hole, selected my geometry as the surface edges of the hole here, and I did a center drill and a drill operation and set up my feed rate. Next, we did the profile around this, and all I did for my geometry here was I selected this edge, one of these two edges here. I just selected this edge going around and this edge here for my profile. And from here, I selected my top of feature, which is the top of the cylinder of the OD there, and then my total depth down at the bottom. And then basically just a basic 2-axis mill operation, profile rough and profile finish. I'm going to skip down to setting up my tool, 1/2-inch flat end mill. I did multiple steps down, set a depth of cut for each pass, so it'll be 4 depths. Set a lead in, lead out, those kinds of options here, so that we can go down about 400 thou each time here. Set an arc lead in and lead out at each depth of cut there. Pretty straightforward. Then we go to the next one is pocketing this area here. What I like in these open pockets now, I didn't mention that earlier with the last part file, is in our geometry selection, in our newer versions, we can select the surface here, and then we can check this box over to the left, detect open edges. So what the software will do is it will understand the areas. Let me cancel out that. There you go. So what it will do, selecting that surface, it will detect the open edges of the surface automatically, start from the outside and work its way in. And I'm doing a depth of cut here for 3 passes, or 3 depths there, and then a profile finish around there. Then we get into the 4-axis machining. Very similar to the additional machine setups. When I right-click Machine Setup 1, go to Additional Functions, we have Insert Setup to add a new machine setup. Then we have Add Index, where I can change it to 90 degrees up and down by picking a surface. Now I don't have a flat surface to work off of, so I'll pick a different coordinate system than I have of the top view here. So if I change it to front, there's down at the bottom, or I can reverse it to where it's going correctly, to the side, which would be this one here, back and forth along the x-axis. I would need it on the front, and I would also need to reverse the direction so that the z-axis is pointed up here, so that the milling tool will go down in the negative z-axis. And that's how I created the index from there. And then from there, just another 2-axis feature, selecting my geometry of the geometry around here, doing a profile rough and a profile finish, just like I did with the previous 2-axis there. That's how I created that index. And then we're focusing on the thread here. And to focus on the thread, we're going to look at 4-axis standard, and then we'll look at 4-axis pro. From here, the 4-axis standard, we went through the index system, which is offered in 4-axis standard, and also this wrapping group option. So if I right-click on Machine Setup 1, it's also under Additional Functions, Add Wrapping Group. I'm selecting the wrapping diameter. It's actually a little bit smaller than the stock here. I measured it out, and if I cheat off of what I had here, it was 1.3 for my OD, and the geometry is wrapped around the cylinder already. So I would check that box as well, and it would be through the X direction. Those are pretty much the 3 big options that we have here to select for a wrapping group. And then from there, basically, I'm just selecting a profile rough and a finish and just following along the geometry. And the wrapping group will wrap the 2-axis feature of the profile rough and profile finish around the cylinder, around the diameter that I set for my wrapping group there. So pretty easy stuff. You just you set up the diameter, you set up the 2-axis feature, and BobCAD will wrap the toolpath around the cylinder for you automatically. Now when we get into it, let's take a look at the simulation for that. Before we get into the 4-axis Pro, because this one is not going to finish the job. We'll take a look at the 4-axis Pro, which would finish the job very well for us, very easy. So we're doing center drill, profile cut, and it's the tool spinning around. So to change the view, we drop this down under workpiece stock, and we view it by tool here, so that it follows around the thread there, and that does that profile cut. Now let's go to deviation to see how much material is remaining. Now the thread looks good, but there's a whole lot of material remaining still, especially on those ridges. So the wrapping group doesn't clean up all of it for the threading here because it's not working off of the surfaces. It's just sort of a dumber tool path, you could say, where it's just working off of the surface edges and creating toolpath offset from the surface edges. I'll turn that off, and we'll look at the 4-axis Pro, which is found if I right-click under Machine Setup 1, and we go to Mill 4-axis Rotary. Now the 4-axis Standard offers the 4-axis Rotary. The 4-Axis Pro offers the 4-Axis Rotary Advanced Rough and Advanced Finish. And that's what I did in this feature here. Advanced Rough and Advanced Finish. The best way I can describe the 4-Axis Standard versus the 4-Axis Pro would be the 4-Axis Standard would follow along the center line of rotation for the tool. If we look at it here. So it'll follow along the center line of rotation for the tool. It'll move up and down in Z, and it'll move back and forth in X while the part's being rotated simultaneously, but it doesn't move X off of the, it doesn't move back and forth in Y off of the center line of rotation while the part's being rotated. So it's sort of like a 3+1 in the 4-Axis Standard, where the 4-Axis Pro offers 4-axis simultaneous machining. And so to look at this one here, we did our 4-Axis Advanced Rough and 4-Axis Advanced Finish. We defined the roughing tool as a 1/2-inch flat end mill. We can zig or zigzag back and forth inside of the area here. What I like here is we have an offset option, or we have offset and spiral. So pretty much all of this is going to spiral around the areas that it can. If it gets into certain areas like these blades here, it'll offset back and forth inside of those areas, but it's really just going to spiral around the group, around the thread here. Next, we have our depth of cut. We have our start and end for the toolpath, so sort of creating a boundary here. This is our boundary option for 4-axis. We also have a radial limit, so if we wanted to start and end at 0 degrees and end at 180 to do half of the cylinder, we could do that here. Other than that, yeah, on that last page, we also have allowance, again, leaving a certain amount of material for the finished pass to clean up. Plunge down into the material, linking for each step over, then our MDI page, then our advanced finish operation in 4-axis. We're using a 1/4-inch ball end mill. We're doing just a zig one direction here rather than zigzag. If we wanted to make sure we're only doing climb mill or conventional milling here. Setting a depth of cut, setting our limits to start and end in a linear direction there. Set a lead in, lead out. And yeah, that's our toolpath here. We'll take a look at our simulation with that toolpath, with this one here. So drilling, profile cutting, and then the 4-axis roughing here. This is really what we were focusing on, was making sure with the surface-based toolpath here, it's not going to get into that pocket. It's not going to have any collisions in that area where the pocket is going around there. I was doing multiple depths of cut down, 10 thou for a depth of cut with a 1/4-inch ball end mill here into that thread, and based on the feed rate, it's saying it's taking about 10 minutes for the cycle time to do the drilling, do the profile first in the pocket, then the threading there, and then the profile inside of the pocket here. So yeah, that's probably how I would get done with all of this this toolpath here. You may be able to use a different tool or toolpath for the threading here, maybe with a threading tool. But if we were using a ball end mill for it, that's probably the best way to go about it, would be using one of these 4-axis toolpaths to follow along the surfaces for it and set a specific depth of cut that you wanted. And yeah, it'll have a limited amount of limited amount of passes for you, so that you don't have to take too much time with your toolpath and things like that. So I'll close out a simulation, and if everything looks good, we can click on Post at the top, generate the G-code, and save it to put it onto a flash drive from there. Please let me know if you guys have any questions with the 3 or the 4-axis toolpaths that we went over today. Again, we went over 3 different part files that customers sent in that you guys had questions on with optimizing toolpath. We went through the 3-axis Pro and 3-axis Premium toolpaths. We went through the 4-axis Standard and the 4-axis Pro toolpaths in this part file as well, to show you guys what the differences are between them and how to optimize your toolpaths for with those milling operations. So yeah, please let me know if you guys have any questions in the comments section on what we went over today. If you have any comments, questions, concerns, what you guys want to see next time in our live event. And our live event will be at the end of the month. So not next Wednesday, but the Wednesday after will be July 31st will be our next live event. Nothing planned so far, sort of TBD for the topic there. We want to make sure these live events are tailored to exactly what you want to see. So please let us know what you guys want to see for the next webinar. If there's any part files or any specific milling operations you guys want to see, we can go through those. Whether it's milling, it could be laser, plasma, water jet. If there's a lot of customers looking at that functionality, having questions with anything there. We also offer lathe with live tooling, and wire EDM machining as well. So yeah, when it comes to any of those topics, please let us know what you're interested in looking at the live events, and we're more than happy to showcase any of those functions in the BobCAD software. But yeah, thank you again for viewing our webinar today, and we hope to see you in the next one. Again, that is July 31st, and same time, 1 o'clock p.m. Eastern Time. And if you have any questions, please let us know, call or email us with any questions that you have in the software program. We're more than happy to help with BobCAD-CAM. And thank you again for viewing the live event today. Hope to see you next live event, and have a great day. Thanks. See ya.